Now let's talk about our ears in terms of the frequencies, and let's talk about what the frequency response of our ears are. Because we listen all day, we don't think about it, but there are certain frequencies we hear more of, certain frequencies we hear less of. So if we were to go and take a pitch generator and just sweep from low to high, all at the same volume, we would hear different pitches being louder and quieter when we sweep through the spectrum. So we don't have flat hearing in terms of frequency flat, from low frequency at 20 hertz all the way to 20,000 hertz. What we're looking at here on the screen, what we're seeing here is we're seeing what our hearing in the general human being, what our hearing looks like in terms of the spectrum. Okay, so there's two ways to look at this. So if we take a spectrum from the low to the high, all at the same level, we'll hear certain frequencies louder and quieter. But let's say we did this sweep and we said, no, that isn't as loud as the last pitch, turn it up. No, turn it down. So if we perceive equal level at all frequencies, this is actually what we're hearing in terms of sound pressure. And you notice when we were talking about that little, your ear canal and the resonant frequency being around 2800 hertz, you notice on this drawing we get a little bump up in frequency at 2800 hertz. And incidentally, 2800 hertz is the frequency you need to be able to hear to understand diction. So maybe there's some relationship between how our hearing developed and speech. So those frequencies, back in the day when we had horrible phones, it all sounded like this, but the frequencies that they would absolutely focus on are those frequencies from 1,000 to 4,000 hertz, because that's what you need to be able to understand. Now, if I was to do this, you can hear that I'm talking, but you can't quite understand what I'm saying. Why? Because I'm blocking out the high frequencies. You didn't quite understand, but you could kind of make it out. But if you only heard those high frequencies, you could absolutely understand what I was saying. Okay? So that shows you this is a drawing of what our hearing looks like if we were to perceive equal levels, and from the low frequency to the high frequencies. So there's numbers here. It's from 0 down at the very bottom, which you can't really see, all the way up 20, 40, 60, 80, and 100. That's level. That's volume. Those are decibel levels. So you can see from this drawing that our hearing response, our frequency response of our hearing, actually changes with volume. And you notice the louder one's a little flatter than quieter ones. It goes into understanding why loud music always sounds better. The louder it is, the flatter it is, the more we hear all frequencies equally. Quieter it is, the less we hear low frequencies and super high frequencies. That goes to explain something about what compression does as well. It balances out all those frequencies by changing the shape of the envelope, because our ear starts closing down and controlling dynamics. Loudness and level are sometimes interchangeable. What I really meant to say if I said loudness, if I said level, I meant loudness. So here's equal loudness contours. Okay? And actually, this research was done, believe it or not, by AT&T. Why? Because they were trying to find out how we understood speech, what frequencies were necessary, because if they could limit the frequencies over the telephone lines way back when, before we had cell phones, then they could actually compress more voices and more telephone calls on the same wire, have worse frequency response, as long as people on the other end could understand. That's all they cared about. So commercial exploitation has helped us understand something about our hearing. The other interesting thing about it is that 3,000, 2.8 kilohertz area is where we hear harshness. Sounds sound harsh. When we're mixing a record and the vocalist is singing really hard, that's kind of where we hear that harshness in a voice. And so naturally what I do is try to take a little bit out to make it less harsh, taking into account the fact that I hear it better. That's why I hear it more prominent than the other frequencies. They usually say somewhere around 80 decibels is best for mixing, because it's not too loud, it's not too quiet, you're not going to damage your hearing, and you're getting an average response from your ear. If you listen loud, it's going to sound better. If you listen quiet, it's going to sound not as good. But when I do mix, I try to vary the levels back and forth. Loudly for a minute, down to medium, and where I mostly spend my time in that range of like 60 to 80 to 90 decibels. And then I really turn it down quite a bit. When I reference, before I say I'm done with my mix, I turn it down real quiet and I just listen, can I hear everything properly at a low level? Because that's about as bad as it's going to sound, and I want to make sure it still sounds okay down there. That's why people have different sets of speakers too. Small ones, big ones, and they reference in their car sometimes to make sure that it translates to all different speakers, because they're all a little different in terms of how they reproduce sound. And I'm getting off topic because we're really talking about how we actually hear the sound once it's regenerated by speakers. But generally speaking, the best level to work at is somewhere in the middle, where doesn't sound too good and doesn't sound too bad. We've got phones or phones. Here's an equal loudness curve measured in phones. Okay, so that's basically understanding a little bit about the frequency response of our ears.